Today we will see vector or cross product of two vectors. You have studied about the scalar product, that is defined as a vector dot b vector will be equal to magnitude of a vector into magnitude of b vector into cos theta, right? Where theta is the angle between the vectors a vector and b vector, right? And here this will give you our scalar value. Similarly, we can define the cross product. It is defined as a vector cross b vector, or we can call this as a vector product. So for this we need two vectors. Let me consider. This is a one vector a vector, okay, and this is the second vector b vector. To define a cross product of two vectors, there exists another unit vector. There should exist one unit vector. Unit vector will consider as n cap, and this unit vector is perpendicular to both a vector and b vector. Is it clear? There exists one unit vector which is perpendicular to both a vector and b vector. In two dimension this is not possible, but it is in a three dimension. Is it clear? There exists one unit vector which is perpendicular to a vector and b vector, and angle is theta, which is between the two vectors a vector and b vector. Then this is defined as magnitude of a vector, okay, into magnitude of b vector. Then in the dot product cos function was defined. Here it is sin theta, and here if you take this one, this will gives you a scalar. But cross product is of a vector will be vector. You need to multiply by n cap, where n cap is the, is it clear? N cap is the unit vector perpendicular to, important one, perpendicular to both a vector and b vector. And one more thing, while taking the angle theta, it should transfer from a vector to b vector. Okay, a vector to b vector. That means this angle should be measured in the direction of a unit vector. Here you can see this, the unit vector is in this direction, right? So angle should be measured from a vector to b vector. You are not supposed to consider b vector to a vector. So theta is from the angle a vector to b vector. Then a vector cross b vector is equal to magnitude of a vector, magnitude of b vector, sin theta into n cap. One more thing, see, if we consider the, we will consider same a vector and this as b vector, okay. Now if I measure the angle from b vector to a vector, now angle is measured from b vector to a vector, so we will consider theta. Next, the unit vector, the perpendicular vector, I mean this is in this direction, right? So unit vector should be in the direction of this one. So we cannot take like this, upwards. So the unit vector will be like this. Is it clear? This is now, this is n cap, right? Unit vector, and this is also a unit vector. Only difference, I mean the direction is opposite. So if it is this is n cap, obviously this will be minus n cap. Is it clear? Vectors are same. See here, a vector, b vector, a vector and b vector, but angle is measured here theta, here like this. So the what unit vector will be in this direction. So this will be minus n. By using this one, we can define b vector cross a vector. Is it clear? It is not a vector cross b vector. It will be b vector cross a vector is equal to magnitude of b vector into magnitude of a vector into sin theta minus n cap. So this can be written as minus of, see here, a vector magnitude of b vector sin theta into n cap. So this is equal to now minus this I can write as a vector cross b vector, right? So this will be now a vector cross b vector. So by this we can say that cross product is not commutative. If you consider the dot product, a vector dot b vector will be equal to b vector dot a vector. But in this case, a vector cross b vector will be equal to minus b vector cross a vector. So this is not commutative. Remember this, vector cross product is not commutative. We will consider one more example. See, let me consider this. So this is one a vector, okay, and this is b vector, and angle between them is theta from a vector to b vector. Now there should exist a one unit vector. So the unit vector will be in this direction. It's in 3D plane, so this will be the unit vector n cap. So this is the direction and here it will be this. If it is B to A, see here, this is now same, this will be A vector and this will be B vector. If it is B vector to A vector, so if it is this is the angle, then unit vector will be opposite to this. This is now n cap, so here it will be downwards. So this is now minus n cap. Is it clear? So here A vector cross B vector is, you have to remember this, A vector cross B vector is not equal to B vector cross A vector, but A vector cross B vector will be equal to negative of B vector cross A vector. Okay? As I told you, A vector cross B vector is equal to magnitude of A vector, magnitude of B vector, sin theta n cap, right? Where theta is the angle between these two vectors, n cap is the unit vector perpendicular to both the vectors. Now here you can see this one, this will be, cross product of any two vectors will be vector. Is it clear? This is a value, this is value, here it will be value, this is a unit vector. So one value is multiplied with a unit vector, so cross product of any two vectors will be vector. If it is any two vectors are parallel, if I consider A vector is parallel to B vector. Now if any two vectors are parallel or collinear, then what happens? Angle between them will be equal to 0. So if it is this is 0, sin 0 will be, this whole term will be 0. Right? So A vector, this is true if and only if A vector cross B vector is equal to 0. 0 vector. Is it clear? A vector cross B vector is equal to 0. Either magnitude of A vector should be equal to 0 or magnitude of B vector should be equal to 0 or the angle theta is equal to 0. If it is A vector is parallel to B vector, if and only if A vector cross product of those two will be equal to 0 vector. If it is this one, A vector cross product of A vector will be equal to 0, right? A vector cross product of A vector will be equal to 0. Since the same line, so there is angle between them will be 0. So A vector cross minus A vector. Can you say? A vector cross minus A vector means if it is this is A vector, minus A vector will be, magnitude will be same but only differs, opposite in the direction, right? So this will be minus A vector, so angle between them will be 180 degree, right? So A vector cross minus of A vector is also equal to 0 vector. In this case theta will be 0, the angle between two vectors will be 0, but in this case the angle between two vectors will be equal to, theta is equal to 180 degree. Okay, and one more thing, here the angle should be between 0 to 180. 0 less than or equal to theta, less than or equal to 180 degree. Remember this. Okay. Now, if it is angle theta is equal to pi by 2. Now, what we can write? A vector cross B vector will be equal to magnitude of A vector, magnitude of B vector, right? Into sin 90, sin 90 will be 1 into n cap. If I consider the magnitude of A vector cross B vector, now it is equal to magnitude of A vector into magnitude of B vector into magnitude of n cap. It's a unit vector, so n cap will be equal to 1. Is it clear? So magnitude of A vector cross B vector is equal to magnitude of A vector into magnitude of B vector whenever the angle between two vectors is equal to 90 degree. Now one more thing, the angle to find the angle between any two lines, the formula is sin theta is equal to, by using this, magnitude of A vector cross B vector divided by magnitude of A vector into magnitude of B vector. Remember this. See here to find the value of sin theta. Sin theta is equal to now A vector cross B vector divided by this one. Now if you take the magnitude on both sides, magnitude of n cap will be 1. So sin theta is equal to magnitude of A vector cross B vector divided by magnitude of A vector into magnitude of B vector. This is the one important formula. Now, see, if I consider, okay, these are the planes x, y and z. So this is x and this is y and this is z. Now here along this direction unit vector I cap, this will be j cap and this will be k cap. Now, can you say what is the cross product of those? See this one. If I write I cap cross I cap, can you say what it is? I cap cross I cap. I mean the angle between them will be 0, right? If I substitute 0 here, sin 0 will be 0. So I cap cross I cap will be always equal to 0. Similarly, j cap cross j cap, angle between them is 0, so this will be equal to 0. And k cap cross k cap will be also equal to 0. What about in the dot product? I hope you remember this. I cap dot I cap will be equal to 1. So this is the difference between these. Okay. And here j cap dot j cap will be equal to 1. K cap dot k cap will be equal to 1. Because their angle cos was there. Here the angle sin is there. Right? Ratio sin ratio is there. So this is one. Now one more. I cap cross j cap. Can you say what it is? In the dot product, what it was? I cap dot j cap was 0, right? And j cap dot k cap was 0. Then k cap dot I cap was also 0. And those were commutative, right? Now I cap cross j cap, just will substitute in this. See, magnitude of I cap into magnitude of j cap into sin theta. Theta is what is the angle between I and j. All the three axes are mutually perpendicular each other, right? So angle between I and j will be 90 degree, right? What is the value of sin 9? It is 1. So I can write 1. And what about unit vector? N cap. This unit vector, listen carefully, this unit vector should be perpendicular to I cap and j cap. Here these are the two vectors, right? Which is the unit vector perpendicular to these two? Obviously it will be k cap. Is it clear? N cap is the unit vector which is perpendicular to both A vector and B vector. Here, this is here I cap and j cap. These are the two unit vectors. Obviously, k cap will be a unit vector which is perpendicular to these two. So I can write that as k cap. So by this I cap cross j cap, what is the magnitude of unit vector? 1. Magnitude of j cap will be 1. So remaining with k cap. Is it clear? I cap cross j cap. Similarly, we can define j cap cross k cap will be equal to I cap. Next one, k cap cross I cap will be equal to j cap. So I told you I cap cross j cap is not equal to j cap cross I cap. It will be equal to negative, right? So if you want to find j cap cross I cap, it will be equal to minus k cap. Is it clear? And k cap cross j cap will be minus I cap. And I cap cross k cap will be minus j cap. So here, to remember these things, there is this one small trick, one method is there. See, if I consider this is I cap, okay, and this will be j cap and this will be k cap. Now it is in the same direction. If I want to find I cap cross j cap, see here it is in the same direction. I to j will be equal to k cap. Now I'll consider j to k. See here j cap cross k cap will be equal to I cap. Last one is k to I. It's the same direction. Observe that k cap cross I cap. K to I will be equal to j cap. Now if I want to find j to I, see here j cap cross I cap. J to I, so it is in the opposite direction, right? So j to I will be equal to minus k because it is in the opposite direction. Is it clear? Minus k cap. If I want to find I to k, I cap cross k cap, I to k, again it is in the opposite direction, so this will be equal to minus j cap. Next, what is remaining? K to j. So k cap cross j cap will be equal to k to j, again it is in the opposite direction. So it will be equal to minus I cap. These are the important things to remember, okay? You have to remember this cross product of any two unit vectors and dot product of a unit vectors. Cross product or vector product, usually we will not use that formula, but to find the angle we need to use that. See, to find a cross product there is a simple formula. I think you might have studied in physics. A vector cross B vector. Let us see what is that. A vector is equal to, we will consider A1 I cap plus A2 j cap plus a3 k cap, okay, and b vector is equal to b1 I cap plus b2 j cap plus b3 k cap are the two vectors. Now we'll find the cross product of that. A vector cross b vector is equal to, let me write that, a1 I cap plus a2 j cap plus a3 k cap cross product with b vector. It is b1 I cap plus b2 j cap plus b3 k cap. Now you have to multiply each and every term. First let me start with this. So a1 I cap cross b1 I cap. So a1 b1 are the constant. What I can write here? See, a1 b1 I cap cross I cap, right? Second will be plus a1 b2 I cap cross j cap. Third plus a1 b3 I cap cross k cap. Next we start with the second term. So it will be plus a2 b1 j cap cross I cap plus a2 this term b2 j cap cross j cap, right? Third term will be a3 to that. I hope you are getting this. a3 b3, just a multiplication is there, sorry, not a3, a2, right? See here, a2 b3, a2 b3 j cap cross k cap plus, again we multiply with the last term. It is a3 b1 k cap cross I cap plus a3 b2, what it will be, k cap cross j cap plus a3 b3 k cap cross k cap. Now see here, I cap cross I cap will be equal to 0. Again k cap cross k cap will be 0. One more j cap j cap. So this will be equal to 0. Now we have to deal with the remaining terms. For that let us write like this. So this is I cap and this is j cap and this is k cap. Now see here, a1 b2 I cap j cap will be equal to k. So this is now k cap plus a1 b3 I cap k cap, direction is ulta, right? It is in this direction, so it will be I cap cross k cap will be equal to minus j cap. So this is now minus j cap. Done with these two, right? Third one, see here, a2 b1 j cap I cap, again ulta, so it will be equal to minus k cap plus a2 b3, right? a2 b3, it is j2k will be equal to I cap, simple it is, okay, plus here a3 b1 k2I, same direction, so it will be equal to j cap. Now remaining with a3 b2 k2j, where is k? k2j, again it is in a ultra direction, so it will be equal to minus I cap. Clear? So we will collect the terms in k cap, j cap and I cap. So I can write I cap into, see here, a2 b3, one more I cap is here, minus, right? So this is minus a3 b2. So clear? See this I cap term and one more I cap term is here. Plus I need to collect the terms in j cap. So j cap, where is j cap? One is this, right? This is j cap, another here it is there. So this will be a3 b1 minus a1 b3 and plus last is k cap. What is that? K cap is remaining with here a1 b2 minus a2 b1. This is the cross product of two vectors. To find this one, we have to use the determinants. You don't need to worry about these things. That just what you have to do is, see, two vectors are given. Just take the determinant, I mean a vector cross b vector, but you should know proof also, okay? A vector cross b vector, determinant of I cap, j cap, k cap. Then coefficient of that a1, a2, a3, b1, b2, b3. Now if you expand this, obviously you get this one. See, I cap delete first row and first column, a2, b3 minus a3, b2, right? Second will be minus j cap, right? Minus j cap, delete this, b3, a1. See here, b3, a1 is in the beginning because we have to take negative. Minus this will be this a3, b1 plus k cap into delete first row and last column. It is a1, b2 minus a2, b1. Just the thing is, what you have to do, whatever may be the two vectors are given, a vector and b vector will be given. To find the cross product, a vector cross b vector, just write the unit vectors I cap, j cap and k cap. Then write the coefficient of I, j, k. In the below this one I should be there, below this j coefficient will be there, this k. Then that is the vector first. Then write the coefficient of the second. Then delete first row and first column, like that you find the determinant of that matrix. It will gives you a vector cross b vector. Simple. Result, important one. Okay, problem based on this is also important. You have to remember these formulas. If a vector and b vector represent a adjacent sides of a triangle, then area of a triangle is given by half into, magnitude of a vector cross b vector, not plus, okay, half into magnitude of a vector cross b vector, area of a triangle. And area of a parallelogram is given by magnitude of a vector cross b vector. Let us prove this one. Let us consider two vectors. This is a one vector, a to b. I'll consider as a vector, okay, and this is the another vector, a to c. We'll consider this as b vector. Now triangle by joining a, b to c. Now ABC is a triangle, right? A vector and b vector are the two adjacent sides. By using this, we have to find the area of this triangle. What we'll do is, just we'll draw a perpendicular C from C to D. Okay, so this is the perpendicular. Now area of a triangle is equal to half into base into height. Base is AB, right? Magnitude, right? Magnitude of length. Base is length, that is magnitude of AB vector into height is now DC vector, magnitude of DC vector. By this we can write half into magnitude of AB vector will be magnitude of A vector into magnitude of DC vector. As I told you, this is a vector A and this is the vector B and this is the angle between them. By using this one, we can define our angle sin theta, right? Now sin theta is equal to opposite by hypotenuse. Length of the opposite side is magnitude of DC vector, right? Or CD vector, magnitude of CD. Sorry, we have considered DC, right? Anything, either DC or CD. Here I have considered DC, so let me take DC only. Magnitude of DC vector, right? Sin theta is opposite by hypotenuse. Hypotenuse is magnitude of B vector. Is it clear? Length it is. So this is a vector B. To find the length, we need to take the magnitude. So magnitude of B vector. So by this we can write DC vector is equal to sin theta into magnitude of B vector. Right? So we'll substitute here. So this is star. We'll substitute in this 1. So that is now area of a triangle half into magnitude of A vector. We got DC vector as magnitude of B vector into sin theta. Magnitude of B vector into sin theta. Now can we write this as half into magnitude of A vector cross B vector? Agreed? So this will be equal to magnitude of A vector cross B vector. What is A vector cross B vector? Is equal to magnitude of A vector, magnitude of B vector, sin theta into n cap, right? If I take the magnitude of this, now this is same, this will be same, magnitude of n cap will be 1. So by this I can erase this, right? I can remove that. So magnitude of A vector, magnitude of B vector into sin theta is equal to magnitude of A vector cross B vector. So this is the important formula. Okay. Similarly, we can prove that parallelogram also. Let us consider a parallelogram. Okay. So this is A, B, C, D. As I told you, two vectors should be adjacent. We'll consider this as A vector, okay, and now this as B vector. Angle between them is theta. Here also let us draw one perpendicular from C to D. Right? Now area of a parallelogram. Area of a parallelogram is equal to base into height. Yes. Here what is base? Length of base will be AB vector. Magnitude of AB vector, right? Into height will be here magnitude of CD vector or DC vector. Both are same, right? Magnitude of CD or DC both will be same. So magnitude of CD vector, right? So magnitude of AB vector is nothing but it's a magnitude of A vector. Similarly, we will define magnitude of CD vector. First, we will define what is a CD vector. To define this, we will define an angle sin theta. So this is now sin theta is equal to opposite by hypotenuse. Opposite is this one, right? So that is magnitude of CD vector. See, similar to this, magnitude of CD vector divided by hypotenuse will be magnitude of B vector. By this we can write magnitude of C vector is equal to magnitude of B vector into sin theta. So substitute this, so this will be now magnitude of CD, right? CD vector is B vector into sin theta. So this is sin theta. So here similar to this one, we can write that as magnitude of A vector cross B vector. So this important thing is you have to remember how to find the area of a parallelogram as well as area of a triangle.